Scene script. How many dimensions can you name? Most people might answer promptly with length, width, and depth, and some may even add time to the mix. But pose this question to a string theorist, and you're likely to get a much more complex answer. According to string theory, a branch of theoretical physics, there are at least 10 dimensions of space, most of which are beyond human perception. Dimensions are the measures that physicists use to describe reality. The 3 dimensions most people are familiar with from school days are the spatial dimensions, width, height, and depth. These are the easiest to visualize. A horizontal line exists in one dimension as it has only length. Add width to it and it becomes a 2-dimensional square. Add depth and it evolves into a cube, a 3-dimensional shape. These 3 coordinates help pinpoint an object's location in space. But space isn't the only plane of existence. Time joins the party as the 4th dimension. Knowing an object's altitude, longitude, latitude, and position in time enables us to plot its existence in the universe as we know it. However, string theorists suggest that reality extends beyond the observable universe. String theory, or superstring theory, attempts to reconcile 2 primary theories describing how the universe operates: general relativity, which applies to very large objects, and quantum mechanics, which applies to very small ones. In a 4-dimensional universe, this theory wouldn't hold up. But when scientists adjusted the math to include 10 dimensions, plus time, their equations worked. After postulating a theory based on the existence of 10 space dimensions, string theorists then faced the challenge of explaining where these new dimensions were hiding. Their answer: these extra dimensions are just as real as the big dimensions we can see, but they are curled up so tightly that they're too small for us to notice directly. This might sound difficult to comprehend, but string theorist Brian Greene presents an excellent analogy. He compares these invisible dimensions to the cables connected to telephone poles. From a distance, a wire looks like a 1-dimensional line. But upon closer inspection, we'd see that the cord is actually round, making it 3-dimensional. While no analogy can perfectly compare unobservable dimensions to objects in the observable world, this one does a good job of illustrating how something so fundamental to reality could be hiding in plain sight. While string theory calls for at least 10 space dimensions and 1 time dimension, some physicists argue for more. Some propose a universe composed of 11 space dimensions. But to truly astound someone asking about the number of dimensions, answer with 26. According to bosonic string theory, that's the magic number, and it's the highest count mainstream physicists are currently willing to entertain.